Alright, my name is Casey Shibler and I am doing a reassessment video on Chapter 14 Standard on properties of materials. This video will be pertaining to the properties of a neutral atom and a point charge. As you can see, I've got my point charge and my neutral atom over here. The distance between these are denoted by the variable r. Let's see. So let's start by the electric field of the point charge creates an induced dipole. So we have our electric field and our dipole, S being the distance between our dipole, R still here, it's the same. So the dipole moment will be directly proportional to the magnitude of the applied electric field and can be denoted by P equals alpha times the electric field, alpha just being the polarizability constant of your material. It should also be noted that the magnitude of this dipole moment right here is P equals QS, which should actually look pretty familiar considering that's in our previous electric field functions. Knowing this, we can take this information and use it to acquire the value for E2 right here at the point charge, where we can derive an expression for the magnitude being E2 equals 1 over 4 pi epsilon naught times 2p over r cubed. We can take p and plug in the function for the dipole moment up here and get the new 1 over 4 pi epsilon naught 2 alpha times the electric field 1 over r cubed. Now this function may look familiar as it is derived from a previous function, the electric field parallel to a point charge, which is 1 over 4 pi epsilon naught 2qs over r cubed. So, since we know the electric field of a point charge at the location of the dipole, we can now plug in our value for E1 right here to get 1 over 4 pi epsilon naught times 2 times alpha over r cubed times our E1 now, 1 over 4 pi epsilon naught times q over r squared. We can just group together our values now and kind of simplify it a little bit. So that gives us 1 over 4 pi epsilon naught squared times 2 alpha times q over r to the 5th power. But what if we wanted to find out the force on the point charge due to the electric field of the dipole? That's fine. We actually went over Coulomb's law, which shows the relationship between force and electric fields, which is F equals Q E2. My apologies, there's actually supposed to be an arrow right here because it's a vector. It'll just be blue for now. And we actually already solved for E2, so we can just kind of plug and chug. And what we get from there is F is equal to Q times 1 over 4 pi epsilon naught squared times 2 alpha Q over r to the 5th r hat. We just kind of move our Q over here, and then we get 1 over 4 pi epsilon naught squared times 2 alpha Q squared times r to the 5th r hat. There's my pretty little diagram for that. See my little f's? They're vectors. But let's take it a little bit further. What if I wanted to find the force on the neutral atom by the point charge? That's not a problem because we just use Newton's third law. Everything has an equal but opposite reaction. Therefore, since it's equal but opposite, it can be denoted by F2 is equal to negative F1, which is equal to negative 1 over 4 pi epsilon naught squared 2 times alpha q squared over r to the 5th r hat. As you can see, we have equal but opposite supporting Newton's third law. And that's how I find the force. Thank you.